Hello, this is the next video in a playlist that I'm calling probability measures, and we're going to look at an extension of a probability measure to all subsets of omega. Now this is a follow-up video to this one, the extension of a probability measure from a field to a slightly larger class of sets. In the proofs, we're going to refer to it as BV1, Background Video 1. Now here's the lemma for this video. Let G be a class of subsets of omega, mu be a measure of G such that G, script G and mu satisfy the lemma in BV1. Now define for all subsets of omega this new measure, which we're going to call mu star of A. And it's really the infimum of all the sets that cover A. So it's all the sets of G, which G has nice structure to it, and G covers A. So, and then you take the minimum. That's this new measure. Then this new measure follows these following properties, and I'm going to come back to that one in a second. So the measure, the new extension, mu star equals mu while we're on G. And mu star, the measure is between 0 and 1 for all subsets of omega. Mu star plus the union of two sets plus, mu star intersection two sets is always less than or equal to mu star of A plus mu star of B. Now the third property is if A and B are subsets of one another, then mu star A is always less than or equal to mu star B. If we have an increasing set of increasing sets AN, so A1 is a subset of A2, which is a subset of A3, and they increase to some set A, then the measure of AN, so mu star AN, goes in limit and equals mu star of A. Now, part B, I wanted to discuss in a little bit more detail that if we take the sets A and A complement, the union is omega, right here. And here, A complement, A intersect A complement's the empty set. Now, the empty set and omega live in G script, so their measures are the same, mu of omega plus mu of the empty set. But this is 1, right? This is 0 and this is 1. And based on property B, it's always less than or equal to mu star A plus mu star A complement, right? So this is actually greater than 1. So this extension that we're proposing here doesn't extend to a probability measure on all subsets of omega. So this is proof that we can't just extend it to all subsets of omega. There has to be structure around the subsets that we extend it to. And 2 videos from now, we're going to take some of these ideas and then restrict the subsets that we extend it to. And that will be a probability measure. So here's the proof of these. So if A is in G, so remember A is any subset of omega, but if it's in G, then these two measures equal. They have to, because since A is its own cover, then it's the infimum of all covers, right? So the measure of all G that cover A, and we want the minimum, well, you just take A. So mu of A is mu star of A. And since the empty set's in script G, then its measure is 0, and the omega is in script G, so its measure is 1. Now if we let A be in omega, let's let G1 be the subset of script G such that it's this measure. So it's the infimum of mu of G for all G in script G, and it's a cover of A. That's the G1 that we want. Now, this probability measure is clearly greater than or equal to 0, right? And the G1 was the one that made these two equal, and that's less than or equal to omega, which is equal to 1. So this measure is always between 0 and 1. And for this property, that's BV1 lemma 2c in the video that we mentioned. Now, if epsilon is greater than 0, and we're going to prove part B, which is this relationship here, we're going to choose G1 and G2 that are, that cover A and B, that are, A and B are subsets of these. And we're going to make it so that this, it's so close to it that it's, if we add a little bit to this set, it goes over. So, and this is such that the measure of A plus some small amount is greater than or equal to the measure of G1. And G2 is defined similarly, that these are so close, that if we add a little bit to the mu star B, then it's bigger than mu of G2. Now, so mu star of A plus mu star B plus epsilon. So what we're doing is we're adding these. So we added these two equations here. And then these two come here. But this property in script G holds. So this is actually equal to this. But the measures of these are slightly bigger than these measures, right, by definition. Now, epsilon was chosen arbitrarily, right? So if we let the limit of epsilon go to 0, then the measure of A and B, so mu star A plus mu star B, is greater than or equal to this measure. And that's what we wanted to show. Now, let's let A and B be an omega such that A is a subset of B. We're going to let G1 be a subset of G2 such that these are the sets that make these equal, right? There's some G in script G that these equal, right? Because it's the infimum. There's some infimum. Now, by background video 1, lemma 2c, we know this relationship. So mu star of A is equal to mu of G1, but since G1 is a subset of G2, these two measures are it's an inequality, but this one was equal to mu star B. So therefore, mu star A is less than or equal to mu star B, and that's what we wanted to show. Now, part D, let's let AN be a subset of A, right? Because this is going to be an increasing set, in limit to A. And we want, then because of this, we know mu star A in is less than or equal to mu star A. And if we take the limit of both sides, we get this relationship. So the limit of this measure is less than or equal to mu star A. Now, let's let epsilon be greater than 0. And for each n, choose a gn that's greater than an. So an is a subset of gn, such that that if we add just a little bit to the measure of an, which is this epsilon over 2n, it's actually greater than the measure mu of gn, right? We're picking sets like that. Now, we do know that A is equal to this infinite union of ANs, right? ANs increase to A, so this union is this. But this union is a subset of GN, which actually lives in G. So thus, the measure of A is less than or equal to, right? So this measure is less than or equal to this measure, right? This lives in G, so it's actually just mu. They're the same. But but the subsets in G, script G, behave nicely. So the measure of the infinite sum is the limit of this, the measure of this union here, right? That it's essentially saying that we can take this limit inside here, right? And they're equal. And that's in background video 1. I'm going to refer you to that. So next we're going to show that the mu star A is less than or equal to this infinite sum, right? We just showed that this limit is less than or equal to A. And if we can show that this relationship also has to hold, it can't be less than or equal to something and greater than or equal to something. That means they have to equal, okay? So we need to show that the measure of this set is less than or equal to the measure of this set plus some small quantity. And then we're done. Because the limit, right, the limit of this is greater than or equal to the measure of A. So then if this is small in here, then we can show that. If we let the limit as n go to infinity to both sides, then this is proven. So we're going to prove it by induction. So let n equal 1, and we're going to pick a G1 such that A1 is a subset of it, such that the measure of A1 plus some small quantity is greater than mu of G1. Now let's assume true for n, and then we're going to prove it for n plus 1, that it has to hold 2. So the measure of I of this union from 1 to n plus 1 is equal to this measure. Okay, now these sets live in script G. So this relationship is true. That's by lemma 2b. Now in lemma 2b we proved that, we added, actually this was over here. So it's the union, it's the intersection of these two sets plus the union of these two sets equals the sum of the measures of those two sets. That's given in BV1 lemma 2b. Now note that since AN is increasing to A1, that means that AN is a subset of AN, the AN plus 1. That means AN is equal to this intersection, which is a subset of GN intersect GN plus 1, because these are covers for those, so this has to be bigger. But that's a subset of this, right? If we intersect or union all these sets. Now, mu of this union of 1 to n plus 1 of G1 is, and if we look at this relationship here, right? So this union is smaller than this. That's actually the hypothesis. They were assuming true for n. So that means this is greater than that. Now, for one set, we can always pick a G n plus 1 that's less than the mu star of A n plus 1 plus some quantity. So this is slightly bigger than this. And then we just showed earlier that this set is bigger than this one, right? The set in here is bigger than AN, right? So this measure is bigger than A star or mu star AN. So if we're subtracting off a bigger quantity, this is going to be smaller than if we subtract off a smaller quantity. So this quantity from this relationship is true. Now the mu star ANs cancel, and we're left with mu star AN plus 1, and then plus this quantity. But epsilon's chosen arbitrarily. So if we let epsilon go to 0, then this relationship holds, which means this relationship holds, right? This is what we wanted to show, because now if we take the limit of both sides, then these two are here. And we showed earlier that that this is less than or equal to this set in limit. But mu star A is less than or equal to this limit, and it's also greater than or equal to this limit, so that implies that they have to equal. And that's what we wanted to show. Well, that's it for this video. Hope you enjoyed that. The next video, I think we look at outer measures. Hope you enjoyed it. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.